continuing from where we left off, we have to consider that, okay, so what follows here is 9, what follows there is 10, then afterwards 11, then finally 12. So then we go to the x-axis, we try 5, but starting from a minimum value of 50, because sometimes it's only nice and neat to start from exact values. Why would we start from 54? So we have to start from the exact values. For example, 50, that's more exact, it's more rounded off. So 50, 55, we try, this is a trial and error before you do it permanently. 50, 60, 65, 70, 75, 80, 85, 90. So it is apparent that this scale will not fit because 98 will not be found on this scale. So remember I told you that we can use 5 or we can use 10, but 5 was better, but since 5 cannot fit, then we have to use 10. You never go wrong with this way of choosing scale. You're always correct. There is no chance of losing marks. So using 10, then this becomes 60, and this becomes 70, this becomes 80, 90, 100. I think that is it. Don't need to label everything. And remember, this is the x-axis. Okay. Then we continue now. We now need to label the points. The first coordinate, each box on the x-axis is representing 1 unit. So to find 54, 54 corresponds to this point. So to label it correctly, we come here. It's 0.79. Each box on the y-axis represents 0.1. So 0.79 is somewhere here. So we label this like that. We put the coordinate there. Then the next coordinate corresponds to, I believe, it corresponds to, if we look on our table correctly, it corresponds to 1.6 for the y value and 63 for the x value. 63 for the x value. Okay, so 63 is somewhere here, 1.6 is somewhere there. So our coordinate will be here. The next coordinate corresponds to 67 for the x-axis. And 2.8 for the y-axis. And 2.8 for the y-axis. So we continue from there. Sorry for the disturbance, the minor disturbance here. So it's 2.8 for the y-axis. So if it's 2.8 for the y-axis, let's find where it is. That is 67 here. It will be somewhere there. And having found 67, then we come to 2.8. It will be somewhere here. So we will meet there. Then the next will be the next value of y will be 6.6, and the value of x will be 80. So the value of x will be 80, whereas the value of this one is 6.6. So let's find where 6.6 is. 6.6 is corresponding to this point. Now, just for the points, make sure that everything is done accurately, because sometimes when the coordinates are cannot be easily viewed, it is tough to do it at the same time, especially in the exam. So we are going to draw a horizontal line corresponding to here, or maybe I don't need a ruler, so I'll draw a horizontal line which I will erase later on. But I'm drawing this horizontal line so that it corresponds to 80. 80, you see where 80 is. 80 is here. So to avoid any chance of mistakes, so that's the point here. 80 is there, 6.6 is there. So our coordinate is supposed to be there. So in which case it is proper for me to then erase this long line here. This allows us to do things in a more proper manner. Then the next one and the final one corresponds to 11 and 98. 98 will be somewhere here. Okay, so reducing it a bit, I think I can go like that. 98. Okay, let me start again. You'll be doing it on a paper, graph paper with a pen, so it will be more perfect. Yours, mine is 9.8 and 11. So let us go where 11 is. So let us continue with our line again. The idea is to make sure that there are no errors when we find 11. So we are here to find 11. So now we know that it's approximately here. So our coordinate will be here. Okay, so I will erase what I have put there. Let me erase it so that we can do our business quickly. So now I've plotted all the points. It would be nice, of course, for me to remove the extra dot. Let me remove the dot to ensure that everything is nice and smooth. So I've removed all the dot. Now the next thing now, according to the question, is what is it? Draw. According to the question, forget about this one. Okay, I had done a different question before. The next part, according to the question, is saying draw the straight line of best fit. So it must be very clear. It's a straight line of best fit. It's a straight line of best fit. It's drawn once with a ruler, the straight line of best fit. So we need a ruler to draw this straight line of best fit. Now my coordinates here are not very perfect here. Some of them, they are too thick. But otherwise, coordinates are not supposed to be this thick. Coordinates are supposed to be thin. Okay, so now we are going to put our ruler and then the line must fit through the points. It must make sure, for example, this, if I were to put it here, it will not be a good line, even if it will be passing through 3 points to some extent, because it leaves the 2 points at the bottom. These 2 points are too far away from the line. If it was 1 point, then we could live with it, but it is 2. So this is not a good line of best fit. So the line of best fit, it must fit. For example, if I put it here, I think this is a better fit. The point at the bottom, the distance from that point to the line and the distance from the second point to the line is almost equal. The point at the top there, the distance it makes to the line is almost also equal. So I think that this is a better line of best fit. Maybe I can twist it a little bit like this, but I think once it's like this, it's a better line of best fit. It is fitting as best as it can. So then we draw our line of best fit. Okay, so I have drawn my line of best fit. I think it is fitting nice and perfect. Okay, next thing now, what is the next question asking from us? The next question is asking, determine the gradient and the y-intercept of this line. Now to determine the gradient, what I would do is you must always, it's a must, it's not like it's a request from you, it's a must. You must draw a triangle on this line of best fit. This triangle, I shall explain some few more things after I've drawn it. That I will start off from here. Choose to draw a triangle on the board line. It allows you sometimes to know some of the coordinates already. Okay, so having drawn my triangle, there are some key things about this triangle. Number 1, the length of the hypotenuse of this triangle to here. that length of the hypotenuse, its length is more than half the length of the line of best fit, which starts from here ending to here. It's more than half. It just has to be more than half. So that's a very big requirement. This triangle must be there. It's not optional. You don't choose that I'm going to find gradient without drawing this line. So now I want to find the coordinates here. So what is the y value, the x value? The x value at this particular point is 100. The x value will be 100. Okay. Then what will be the y value corresponding to that point? I think the y value corresponding to this point is 11.3. Okay, then next let's find the coordinates of this point. Obviously the y value is 1, but the x value, I think that since it's coming after this point is actually 57, so that's approximately 57.5. We can say 57.5. Okay, that is fine, I think. So let me erase it to make it more neat. Okay, so that point is 57.5. Okay, so now we have to choose which ones do you want to call coordinate 1 and coordinate 2. For example, I'm going to call these ones coordinate 2. I'm going to call these ones coordinate 1. Now, having done that, I'll come here and write coordinates 1. Coordinates 1 is 57.5 and 1. 57.5 and 1. So where we are going to look for the gradient, coordinate 1 is 57.5 and 1, whereas coordinate 2 is 111.3. 111.3. Okay. Having found these coordinates now, remember the question is asking us to find the gradient and the y-intercept. So for gradient, we just use the equation for gradient. Gradient is y2 minus y1 over x2 minus x1. So then the next thing that we do is we have to find gradient. We take the value of y2. The value of y2 is 11.5. y1 it's 1. So it's 11.3 minus 1 over the value of x2 is 100. So it's 100 minus 57.5. This, I'll punch it in the calculator. I'll say 11.3 minus 1 over 100 minus 57.5. This gives us 0.2. This gives us 0. Yes, that's fine. Gives us 0.242. 0.242 if you leave it to 3 significant figures, and we can write the gradient in this space, 0.242. Okay, next we are saying here that okay, usually to find the y-intercept I use this equation where this is the y-intercept. So maybe to make it a little bit more clearer, I'll write this to be y-intercept so that we're more clear. So C is the y-intercept. I find it personally by saying y1 minus m yx1. Who is m? M is the gradient that we just found there. So I'll just take the value of y1. The value of y1 is 1. So I'll come here and I'll say 1 minus the value of m is the gradient that I just found, which is 0.242 multiplied by x1. The value of x1 is 57.5. So when you calculate this one, you find that it gives us a y-intercept of 12 minus 12.9. Okay, so it's minus 12.9. I'm just leaving it to 3 significant figures, no problem. Minus 12.9. So this much part of the question is finished. So we go to the next part of the question. So do not mind what I've done, some of the things that are there. Let me erase there from my previous example. Let me erase this. So when you come to this question says, first and foremost, it says, it is suggested that E1, E2, and X are related by the equation E2 over E1 is equal to Px minus X, where P and constant and Q are constants. Using your answers to D3, determine the values of P and Q. Our answers to D3 were the y-intercept and the gradient. So you are supposed to determine the values of P and Q. But if you come to understand this one, you can agree with me that this one was plotted on the y-axis, E2 over E1. This one was plotted on the y-axis. Then this X was plotted on the x-axis. So it is apparent that this is on the x-axis. And to make matters worse, the graph that we found was a straight line, meaning that it will obey this equation of a straight line. So the graph of E2 over E1 that we drew against X was a straight line graph, meaning that if we are to compare things from this equation, this M, it should give us P. This plus C should give us minus Q. Who is M? M is the gradient of that graph. And who is C? Plus C is the y-intercept of that graph. So how do we find? We have found the gradient already of the graph, and we found the gradient of the graph as 0.242. We also found the y-intercept as equal to, remember it's minus Q, y-intercept is equal to minus 12.9. So the gradient is equal to P as I have shown there, and the plus C is equal to minus Q. So the y-intercept is equal to minus Q. That's why I then say y-intercept is minus Q, which is equal to minus this. If we divide both sides by minus, we get that Q is 12.9. So as a result, we come here on this part, we write what we've just found. We say, okay, the P value of P is 0.242. The value of Q is 12.9. Now, the next thing now they said is give appropriate units. So to give appropriate units, I must show you how we find appropriate units. To find appropriate units, we must be very careful. Firstly, it was known from the table that this does not have any units. Now, you must understand also that in physics, in mathematics, even in real life, we cannot take, let's say, South African rands, 5,000 South African rands and 5,000 US dollars. We add these two currencies and then we say that we have 10,000 US dollars. It doesn't work that way, because 5,000 South African rands, even though there is the 5,000, but its value is different from 5,000 US dollars. So what do? We add only US dollars, or we add only rands. And when we add rands, we get our answer in rands. When we add dollars, we get our answer in dollars. So here, if you check, you can see that there's a subtraction sign there. So there is no way px can subtract q if they don't have the same unit. And the answer that they get must also have the same unit as px and as q. So if that is the case, then it also means that the unit of E2 over E1, which is no unit, is also the unit of Q, is also the unit of Px. So to continue further, if the unit of Q is, there is no unit for Q, then we need to find the unit for P. But Px has no unit. So we say Px is equal to 1. The unit of x is centimeter. So then we divide both sides by centimeter. So the unit of P is 1 over centimeter, which is per centimeter. That's why you see that P here, I gave it the unit of per centimeter. Then we proceed, of course, to the next part of the question. We need to read the question carefully and understand it. The question says the distance between string loop A and the center of the row W is W. I believe we can see this W. That's the distance between the string loop A and the center here. As shown in figure 1.4. P and Q are inversely proportional to each other. What does that mean? This means that P and Q are each inversely proportional to W, which means that P is inversely proportional to W and Q is also inversely proportional to W. Okay, fine. Let's continue reading the question. Students repeat the experiment with a loop A placed further from the left hand end of the row. So loop A is going to be placed further from the left hand end of the row. From the left hand end of the row, further from, meaning that loop A is being moved to the right. So if it is being moved to the right, it means that W is decreasing. So W decreases causes Q to increase, and W here decreasing causes P to increase. Okay, fine. The question then asks, sketch a second line on the graph to show the expected results. Remember, it's a sketch, so you don't need to values. You just need to sketch a second line on the graph to show the expected results. Label this line W. So how do you sketch such a graph? Remember, such a graph has a bigger value of P and a bigger value of Q. But remember, the y-intercept C was equal to minus Q, which means that if the numerical value of Q has increased, C has just become more negative. Because if C was minus 12.9, now maybe it's now minus 15. So it has become more negative, which means that the y-intercept has gone even down. But P is corresponding to the gradient. So if P is corresponding to the gradient, when P increases, it means that the gradient has also increased. So if the gradient has increased, then it means that the graph, the straight line, would be more steep than the previous one. So we are going to draw a straight line which is steeper than the previous straight line that we had. So to draw a straight line which is steeper, I do not think that that is so tough. So what are we going to do? I'm going to use my ruler. Obviously, this line must cross here. It doesn't have to really cross, but it must just be steeper, showing that it has a steeper gradient and it will have an y-intercept which is lower than this other one. So that's my line W. So then I label it W because they wanted us to label it W. So the question is finished.